I'm going to go over the unit 1456 review FRQ that's optional student practice in AP Classroom. So here we're given a function g defined on a closed interval, and it consists of two linear pieces and a semicircle. And then f is defined as 3x plus the integral from 0 to x of g of t dt. First thing we're asked is to find f of 7 and f prime of 7. So let's start out with f of 7. So we're just going to replace x with 7 in both places. Oops, not equals. Plus integral 0 to 7 g of t dt. This is going to be 21 plus, all right, let's look at our graph. So integral from 0 to 7 would be this area, which is considered negative, because it's below the x-axis, plus this area, which is going to be positive because it's above the x-axis. So I have a semicircle and a rectangle, so that circle has radius 3, so it's going to be, that area is going to be negative pi times 3 squared, but then divided by 2 because it's only a half circle. And then this one is just a rectangle, so base times height, 1 times 3, so that has an area of 3. All right, so here's what we have, plus negative 9 pi over 2, and then plus 3, so we get, I suppose, 24 minus 9 pi over 2, and that's our f of 7. All right, so f prime of 7, so first let's find f prime of x. So f prime of x, taking the derivative of that is going to leave me with 3 plus g of x, and that's by the fundamental theorem of calculus part 1, which tells us that if we try and differentiate an accumulation function where the lower limit is a constant and the upper limit is x, we just end up with g of x. All right, so that means f prime of 7 is 3 plus g of 7. So we just need to find the y value of g at 7. So back to my graph, the y value of g at 7 is 3. So 3 plus 3 is 6. So f prime of 7 is 6. All right, B, find the value of x in the closed interval, negative 4 to 3, at which f attains its maximum value. Justify your answer. So what we want to look at, since it's a closed interval, we want to find critical values, which is where f prime of x equals 0. So remember, f prime of x was 3 plus g of x. I'm going to set that equal to 0 and solve. So that's going to get me what, g of x equals negative 3. So let's see if we can find where g of x is negative 3. Okay, so g of x hits negative 3 here at the bottom, and so that is at the value of 3. So that's at the x value of 3. So if I go back, that gives me that x equals 3. So if I'm trying to find a maximum value on a closed interval, I'm just going to use my extreme value theorem, which is the maximum, absolute maximum, can occur at the endpoint, so f of negative 4, or a critical value, f of 3. Well, our critical value happens to also be the endpoint of our interval, so we're just going to look at these 2 points. So let's first find f of negative 4. which is going to be 3 times negative 4 plus the integral from 0 to 4 of g of t dt. So that is negative 12 plus, let's go back and look, the integral from 0 to 4. I'm sorry, not the integral from 0 to 4. Let me go back on that. The integral from 0 to negative 4, right? And so what I have to do to deal with that is, since my upper limit is smaller than my lower limit, I'm going to swap them and negate the integral. So negative 12 minus the integral from negative 4 to 0 g of t dt. There we go. So now let's take a look at our so the integral from negative 4 to 0 would be this area, which is a triangle. And that area is just going to be half the base times the height, so half 4 times 2. So that's equal to 4. Alright, so we get negative 12 minus 4, negative 16. Alright, f of 3. Okay. Alright, so f of 3 is then 3 times 3 plus the integral from 0 to 3 of g of t dt. Whoops. Move some of this. Alright, so if this is 9 plus, let's go back to our, we're looking at this, which is a quarter circle, but remember that's negative area. It's below the x-axis, so it's going to be pi times 3 squared over 4, and it's going to be negative, so it's going to be negative 9 pi over 4. So 9 plus negative 9 pi over 4, or 9 minus 9 pi over 4. Alright, so which one of these is the maximum, f of 3 or f of negative 4? So f of 3 is going to be the larger number, so this will be the maximum. Alright, so for each of the limit as x approaches 0 from the left, g prime of x, and the limit g prime of x as x approaches 0 from the right, find the value or state that it does not exist. It's a little bit of limit practice here. So as we approach 0 from the left of g prime of x, so they're referencing the slope. So approaching 0 from the left, we're coming in on this side, so it's just going to be the slope of this line. And they did tell us that this is a line segment, so we can just find the slope of this line by looking at two coordinates, right? So this is, for example, negative 4, 2, and here we have negative 2, 1, and so that slope is going to be, I'll just do 1 minus 2 over negative 2 minus negative 4. So what is that? Negative 1 over 2, so negative 1/2. All right, from the right, as x approaches 0, g prime of x from the right, well, this is approaching a vertical slope. Vertical slopes do not exist. I'm just going to say that limit does not exist. All right. So last part, another limit finding. Let's see. So we're finding the limit as x approaches -2 of f of x. Remember that f of x equals 3x plus the integral from 0 to x of g of t dt. So if we did a direct substitution and I just plugged in -2, I would have a little bit of a problem. Because we can see in the denominator, this becomes e to the 0 minus 1, which is 1 minus 1, which is 0. So my denominator becomes 0. My numerator, let's see, f of -2 would be -6 minus the integral from -2 to 0 of g of t dt. And if we look at that, the integral from -2 to 0 is this. So, sorry, what is that? Base, half base times height, so half 2 times 1, so 1. So my numerator is going to be, that's 1. Oh, sorry. No. So that's -6 minus 1, which is -7. So my numerator is going to be -7 plus 7, which is also 0. So that's 0 over 0, which is indeterminate. But the good news is that means I can use L'Hopital's rule. So we're going to do that. So remember, L'Hopital's rule says we're going to try to reapply that limit, but we're going to take the derivative of the numerator and denominator separately. And that's going to be f prime of x over, all right, derivative of the denominator, so we would have to use chain rule, so it's going to be e to the 3x plus 6 times the derivative of 3x plus 6 is just 3. Okay. So now let's try our direct substitution. So we want to look at f prime at 2, at -2 rather, over e to the 0 times 3, 1 times 3, so that's 3. So now what's f prime at 2? Well, f prime at x, remember, is 3 plus g of x. So f prime at -2 is 3 plus g of -2. And so for g at -2, we're just looking for the y value of g at -2, which is 1. So 3 plus 1, which is 4. And my final answer comes out to 4 over 3. Okay, folks, I hope it helps.